Ever wonder what's really happening behind the scenes when you send an email or stream a video? Well, today we're pulling back the curtain on the internet's hidden blueprints, the OSI and TCP IP models. Think of these as the invisible rulebooks that make our entire digital world even possible. So, have you ever really stopped to think about it? How do billions of totally different devices, your phone, my laptop, a server halfway across the world, all manage to speak the exact same universal language? It's a huge problem, right? And that's the core challenge these networking models were created to solve. All right, first up, let's talk about the OSI model. The best way to think about this one is as the perfect universal blueprint. It's kind of like the theoretical gold standard for how network communication should work in a perfect world. And when you think of the OSI model, you got to remember one number, 7. It breaks down the super complex process of network communication into 7 distinct, much more manageable layers. Each layer has a very specific job to do, creating this step-by-step journey for your data, from the app you see on your screen all the way down to the tiny electrical signals buzzing on a wire. Now, what's so brilliant about this stack is how the data flows. It starts at the top, the application layer you're interacting with, and moves all the way down to the bottom, the physical layer, with all the cables and hardware. The real magic is that each layer only has to talk to the layers directly above and below it. This creates a beautifully structured and, super reliable system where every single step is clearly defined. But here's the thing. The OSI model is the theory. It's not what actually runs the web today. For that, we need to look at the TCP/IP model. This is the practical, streamlined version that really became the internet's reality. And right away, the difference is just obvious. Instead of 7 layers, the TCP/IP model slims everything down to just 4. It's a much more pragmatic approach, less focused on perfect theory and way more focused on what actually works efficiently out in the real world. These 4 layers, this is the backbone of the internet you're using right now. It all starts at the application layer, where your browser does its thing, then moves through the transport and internet layers that manage all the data packets and routing, and it finally ends up at the network interface, which connects to the physical hardware. It's a way more compact stack, for sure, but it gets the exact same job done. Okay, a quick but really important clarification here. As you look around online, you might see a 5-layer version of the TCP/IP model. And while that's a common way to teach it, it's important to know that the official internet standard, the primary source document, actually defines the 4-layer model we're talking about today. Just a little heads up. So we've got the 7-layer theory and the 4-layer reality. How do they actually map to each other? Let's put them side by side for a little showdown. This table just lays it all out perfectly. Look at how TCP/IP's application layer basically does the job of the top 3 OSI layers all by itself. And you see the same thing at the bottom, where the network interface layer bundles the jobs of both the data link and physical layers. The big takeaway here is that TCP/IP didn't just throw out the rulebook, it just found a more efficient and practical way to get things done. Which, of course, leads to a pretty logical question. If the internet actually runs on TCP/IP, why do we even bother learning about the OSI model? Why do both of them still matter? Well, the answer really comes down to their very distinct roles, one for theory and one for practice. Here's the key distinction you need to remember. The OSI model on the left is a reference model. It's the universal guide for understanding and teaching networking concepts. Meanwhile, the TCP/IP model on the right is an implementation model. It's the practical description of the actual architecture that powers the internet. So let's nail down the final takeaway. Think of it like this. The OSI model is the detailed architectural blueprint. It's absolutely perfect for learning the fundamental rules and for troubleshooting when things go wrong. TCP/IP is the powerful workhorse that was built from that blueprint. It's what actually gets the job done every single day. The structures are a little different, sure, but the core rules are the same. And ultimately, understanding the blueprint makes you a master of the workhorse. And all this brings us to one last big question for the future. These models were designed decades ago, and they have served us incredibly well. But as our digital world just explodes with the complexity of AI, the Internet of Things, and technologies we haven't even dreamed of yet, you really have to wonder, are these blueprints built to last forever, or will we eventually need a completely new model?